super basic one-step equations. As I was talking a minute ago earlier before a bunch of you guys showed up, slow down is the first thing I can tell you. Is just be very, very purposeful when you're doing these, because a lot of these are not hard and you're going to mess up because they're not hard. So you know the inverse. We know that 14r is 14 times r. So this is multiplication. And the idea is that you have to use your inverse operation. And if I ask you in conversation, what is the inverse of multiplication? Very few of you have a hard time telling me what the inverse of multiplication is. Super easy. We would divide. And then so we're going to divide by 14 because that's the inverse of multiplication. And 14r is 14 times r. The other big misconception is we mess up and leave off our negative. A negative divided by a positive or a negative times a positive is going to give me a negative. So in this case, r is going to equal a negative 14. And we are solving for the variable, so we wanted to get variable by itself. And again, it was attached by multiplication. Hopefully that is not terribly complicated. So then again, and you're going to be rolling your eyes at this point because some of these are going to be silly, silly, silly easy. But I'm trying to show you what the hard stuff is. You guys call it hard stuff. How it's not hard. It's just a matter of keeping your brain on straight and not getting upset. All right, so negative 4 times x. Again, so negative 4x. This is multiplication. And so we got to do the inverse. And whatever you do to one side, you have to do the other. So since this is negative 4 times x, we're going to divide both sides by negative 4. A negative divided by a negative gives me a what? Somebody type in the box and tell me. Yes, good job. So negative 40 divided by a negative 4 is going to give me a positive 10. And so it's the inverse, because ultimately this problem is saying negative 4 times what gives me a negative 40. Now, depending on who you had in middle school, who, if they were big mental math fans, you probably could answer that with no question, no problem. You probably didn't have to do the math. So just bear with me again. They feel easy, but the reason is you have to understand how to undo when they start getting really big and ugly. So if you're great at mental math, go you, but pump the brakes just a hair, because we're going to get to things where it won't work as easily. All right, so simple equations. Now, these are called, or the beginning stages of literal equations. Literal equations. And I'm giving you that name in case you want to go, I don't know, Khan Academy, Google, write me an email me and tell me how much you hate them. You know, all this, send them a hate Valentine tomorrow, whatever you feel about it. So literal equations. And all that is saying is that it's never going to be x equals 10. X equals 4, x equals 174. It's never going to, because there are multiple variables. So that means there's more than one letter. So if you didn't like one, like I said, hold on to your britches because you're going to get extras now. But just like the ones before with the numbers that were super easy, this is 9 times a. So we're looking at a multiplication problem again. And the inverse of multiplication is what? Yep, exactly. So this is 9 times a. I want to solve for a, so I need a by itself. So anything attached to a has to be undone. So we're going to undo multiplication by dividing both sides by 9. Don't panic. So now I have u divided by 9 equals a. The question says solve for a. So here's where people start to panic, because you look at that and you go, am I done? I don't know, that's ugly. But it wants to know what is a. And this says a is u over 9. Or a equals u over 9. And a is just on the right-hand side rather than the left-hand side. So same thing for number 6. If we're solving for a, I have to get it by itself. It is attached to that negative 9 by multiplication. So I'm going to divide by negative 9. And I end up with g over negative 9 equals a. A is now by itself. You are done. It is just ugly. It is not its fault that it is ugly. Just happens. And you have to stop. Because once you have a G and an A, you can't get into anything better numerically. It won't get any, you can't simplify or reduce or do more math. It's just moving the variables around, which is why you have to understand the inverse. All right, another single step easy equation, hopefully. This is x divided by 18 equals 11. So if we're going to solve for x, so x divided by 18, so this is division. And just like before, we're wanting to undo because we're trying to get x by itself. And we have both sides of the equal marks. So the undo of division is going to be multiplication. So since this is x divided by 18, we're going to multiply both sides by 18, which is going to give us x equals 11 times 18. Not likely to be part of your calculator inactive portion of your test just because that number is really big. If it had been like numbers like 2 and 7, then think about you have to be able to do, if it's a reasonable that you have enough fingers and toes, or your basic 1 through 12 multiplication tables, those are fair game for calculator inactive. When they start getting a lot larger, like 18 is a little bit big for 9. So again, just flipped sides. This is k divided by 20. So the inverse of division is getting multiplication. So because it's k divided by 20, we're going to multiply both sides by 20. And so 7, that's a negative 7. Negative times a positive gives me a negative 140 equals k. Everybody okay so far? Do you feel like you're getting set up for the trick because they're too easy? All right, now, again, this is the same style problem. I will say these are a little less than ideal because what you're solving for on that first one is in the denominator, but we have to clean up fractions first. Nobody likes fractions, so we want to get rid of those as much as possible. So as soon as you can change in your brain that a fraction is a nasty little fraction and that it is division, and you can undo division super simply by multiplying, then he's no longer quite as scary, hopefully. So this is 2 divided by x. We want to end this equation with an x equals because that's what we're solving for. But since it's in the denominator, we can't get to x equal yet without getting him out of the denominator. So to do that, 2 divided by x, to get him gone out of the bottom, we're going to multiply both sides by x. This x goes away. X times z, can't make him any better because they're not like terms, equals 2. Now they want x by itself. What letter is over there with x right now? Yep, z. How is z attached? That's the number 9. Sorry, Ela. That's like problem number 9. So disregard that 9. The x is in its place. So x times z equals 2. Yeah. So since it's x times z and I want x by itself, how can I get rid of the z? What would be the inverse of times z? Yep. And just because it is division, good job. So x times z, to undo times z, we're going to divide. Trick question, what am I going to divide by? Ooh, close. If we divide by x, then we put x back in the denominator, and that's no good, right? If I divide by 2, I'm not getting x by itself. So that 2 is over here in his own room doing his thing. There you go. There you go. There you go. Z it is. So we're looking at x. So I like to look at this as like 2 different classrooms. It's not a great story because we're not in a classroom anymore. But you know, like your neighbor's classroom. They're over there doing their thing, no big deal. I need to get this x by itself. So to get x by itself, I have to move z because he's on that side. What I've taught a lot of students in the past who didn't just see like what they needed to move right off the bat. If you put a box, and I mean even in pencil, it's the craziest thing, math 1 to math 4. Still, if you put a box around whatever you're solving for, so in this case it said x, I'll put a box around x, and I look at you and I say, what's over there with x? You're going to tell me z, no question, right? How is z attached to x? Multiplication, just like you guys answered with no problem. And that means we need to do an inverse operation. So the inverse of multiplication is division, like you just told me. And then we messed up and we started making stuff up. Think about the conversation we're having. We didn't say 2 was in the way. We didn't say anything of that nature. We said z was in the way. Just like a was in the way here, or 9 was in the way here. So because 9 was in the way, we divided by 9. Because 9 was in the way, we divided by 9. So now z is in the way. Sorry for the blurriness. Hopefully they don't make you nauseous. We're going to divide both sides by z. So that's going to leave me with x equals, and then don't overthink it. This would be one of those things where if you don't write your math down and you do mental math and you don't write neatly, you are going to rock your own world. If you do not write this like a 2 divided by z, then when you go something about from here to your final answer, you guys make up wild stuff. So be very careful. So 2's on the top is divided by a z. And I just put the line in there so it doesn't look like a 2. So 2 divided by z, we're done, we're out. X equals 2 divided by z. Okay? Don't panic. If your head's swimming, just hang in there. Like you'll see on tomorrow's post, you just have to do a ton of these. Like you just have to commit, stay positive, coach yourself down, don't panic. We're going to get it done. All right, so number 10, we're going to solve for x. All right, I'm going to take that minus and I'm going to ignore it and put the minus with the top so I know that it's attached to a number. Because if it's a -3, great. If it's a -2, fine. That means the 3 is positive. I'm just leaving it on the top because I feel like I do a better job of keeping up with things when it's attached to the x and it's in the numerator. Denominator is just where usually people mess up. So I'm looking to solve for x. Looking at this equation, what's your least favorite part of this equation? What number? What part of this equation is typically what? So -3 is a problem, right? But most students hate fractions, right? Like we don't really like it when there's a fraction. If you could just give us whole numbers, life would be so much better. I'll probably set you up for that one because I haven't talked to you guys personally enough to know whether you hate fractions or not. But denominator first. So we're going to get rid of the 2 in the basement. How is that 2 attached in this problem? What operation is that 2? Yes, that's -3x divided by 2. And that's just a vocabulary change in your brain. And so the inverse of division is going to be multiplication. Disregard that 10. See if I can actually make it go away. Oh, nope. Whiteout's gone. So we're going to multiply both sides by 2. That's going to get rid of these 2. And that's going to leave me with 2g equals a -3x. Now again, we're trying to get x by itself. So that's a -3 attached to that x. How is that -3 attached to that x? What operation is that is right there? -3x is what operation? Yes, good job. -3 times x. And you're going to hear me keep saying this because if one day it's going to stick in your brain and you're going to start hearing it my way. So -3 times x. Instead of we've gotten used to just be a -3x. And the reason it's beneficial is when you know it's -3 times x, then the next thing when you're stuck is, well, how do I undo multiplication? As you guys have mentioned numerous times already, we're going to divide. So we're going to divide whatever we do to one side, we have to do to the other side. X equals, because these guys turn into a +1, 1x is assumed, so x is by itself. Again, from here down, we make stuff up. Exactly what you see. So 2 times g, what we did first, and then we divided by a -3. And you're done. It's ugly, so be it. Okay? All right. I am going to skip that one because I feel like it's going to make your head hurt. Tomorrow they're going to be better. Again, your head's maybe hurting right now. Tomorrow it will be better because you're going to see more and more and more. I just wanted you to have the upper crust, the heads up that it's coming. All right, so 2-step equations and just multiple operations. This is not a 2-step. Sorry, we'll get to 2 steps. Basic equations. So this is what I like to call the Great Divide. Big thing. That line, it's really silly, but it keeps you from shoving everything to one side. Because when you start doing positives and negatives, you guys magically put everything on one side. So I highly recommend drawing a Great Divide line. I want to solve for r. So what is on the side with the r right now that we would like to get rid of? Yep, it is a 5. How is that 5 hanging out with that R over there? What operation? Yep, addition. You guys are killing it. Like, killing it. So what is the inverse of addition? And remember, yep, subtraction. And remember, inverse just means opposite. Inverse means undo. We're undoing something. So because this is R plus 5, to undo it, we're going to subtract 5 from both sides. And that's going to give me 18 equals R. And you're done. Walk away proudly. All right, so just for good measure, because I feel like maybe, hopefully, we just put some wind back in our sails. If I'm looking at number 14, I got my great divide. I always love calling this, it's usually my favorite thing to teach, because I call the X or the variable or whatever they're solving for the stinky kid. You know the stinky kid. You've been in a class or in a room or in a store with the stinky kid. And you don't want to say anything, but you want to undo everything around them so they can be by themselves and enjoy their own stench, right? So we're getting everything away from the stinky kid. And number 14, what's over there with X? My stinky kid. Yes. How is it over there with X? Is it a happy positive or is it a negative? Subtraction, right. Now, subtraction is the same thing as adding a negative. Again, just trying to change vocabulary and conversation in your head. So subtraction is the exact same thing had this been written X plus a negative 17. That means you're still taking 17 away. Because again, I'm used to a lot of students getting a little anxious with positives and negatives. As long as there's a minus in the front, whether it be subtraction or a negative, that means we're taking it away or we're losing it. So this is subtraction. The inverse of subtraction is going to be what? Yeah. So we're going to add 17 to both sides. And you chose 17, not 29 or negative 29, because you're trying to get the stinky kid by himself. So this is like classroom number 1. This is classroom number 2. We're trying to get everybody away from the stinky kid. So if I'd moved the 29, I'd put more people in the classroom with stinky kid, and that's not solving our problem. So we now have negative 17 positive. So we're done with that. And we have an X. Now, negatives and positive. This is my conversation. The way I make this makes sense to me. This means I owe you $29 because it's a negative, or I spent $29 and I'm at the store, right? I have 17 because that's a positive. So if I owe you 29 and I pay you 17, do I owe you still, or am I in the plus? So if I owe you $29 and I hand you $17, are we in the good? Can I go away and never owe you money again? No, right? I still owe you money. So that means you know this answer is going to be a negative because I owe you more than I'm giving you. So this is going to be a negative 12 because that means I still owe you $12 after I paid you that 17. So every time you see a negative, somebody owes you money. Again, if you change that conversation in your head, I guarantee you will be much better at positive negatives. Number 15 is a two-step equation. Not a big change, but we got to make sure we do it in the right order. All right, so we did our great divide. Here's our stinky kid. The furthest guy, like thing is stinky kid, I used to tell the story of like if people were getting in a fight in a classroom, you're not going dead to the fight first. You're moving kids out of the way to get to the fight if you're the teacher, right? She's moving everybody away until they get to the guy. So, who is over there in the stinky kid room, but not on top of him? Not with him? What number? Yes, that negative 8. So that's what you want to move first. That minus 8 or plus a negative 8. And the inverse of that plus a negative or minus is going to be add. So we're going to add 8. Add 8. We have a positive 16. So that means I had $16. I gained $8, which is $24 equals 6V. Now we're looking at the problems just like the first page. That's 6 times V. So 6 times V, the inverse of multiplication is what? Yes, that's exactly right. What number am I going to divide by? Because division is the inverse of multiplication. What am I trying to undo? Good. You're undoing that multiplication of 6. Because again, your goal is to get V by itself. So 24 divided by 6 is positive, positive. So I end up with that positive 4. Good job, guys. And thank you so much for chatting in the box. Can't even tell you how much I love that. All right, 16, 17, 18. This is where people start getting a little itchy. Hang with me. It's just a matter of seeing enough of them. All right, we're looking at our great divide here. We're going to go as small as possible with our stinky kid. We have a fraction. We hate fractions. If that fraction is not, like, if there's nothing outside of the fraction, you're just looking at top to bottom. So like in number 17 and number 18, there's things happening outside of the fraction. 16, it's a whole fraction, equals -1. Whole fraction is -1. A fraction is what operation? Yes, it's division. So that's k minus 8 divided by 8. How do we undo division? Woo, yeah. So for k minus 8 divided by 8, so to undo it, we're going to multiply both sides by 8. And that just gets rid of the ones on this side. And then I end up with k minus 8 equals a -1 times 8. That's a negative times a positive is going to give us a -8. A -1 times 8. Now, Stinky Kid is not by himself yet, so we are not done. What do I need to do to get Stinky Kid by himself? Yes, add. Good, good, good. So I'm going to add 8. Add 8. So K equals, if I owe you $8 and then I pay you $8, how are we standing? Yes, we're at a 0. We're done. We're even. No more conversation about me owing you money anymore, right? Beautiful. Perfect, perfect, perfect. All right, so number 17 and 18. Again, a fraction, but slightly different because the work is happening. There's things happening outside of a fraction. So big, great divide. And again, that is just so you don't shove everything by accident to one side because magically equal marks start disappearing. I'm going to box in my Stinky Kid, who's in a fraction. What is on the outside of the fraction, but on the side with Stinky Kid? Yep, -3. Good. And -3 is the same thing as subtraction. So to undo subtraction, what am I going to do? That's it. I'm going to add 3. Add 3. Be careful. Again, the neatness of how you write has always not really made a difference because you've been able to do mental math. Be careful. I owe you $8. I hand you 3. Where are we sitting now? Do I owe you? Yeah. I still owe you 5. Perfect. Now, Stinky Kid is still not by himself. But looking at this, back to like our first couple problems. That's n divided by 3. Inverse of division, as you told us in the last time, is multiplication. What am I going to multiply by? Good. You're multiplying by 3 because the problem, the quote-unquote problem, is that it's n divided by 3. So what we're trying to fix or undo is get rid of the 3 underneath the n. So n is now by itself equals negative times a positive is going to give me a negative. And 5 times 3 will give us 15. Awesome. I think you guys are better at this than I thought you were going to be. Hopefully you're not like completely miserable yet. Now, again, just one more step further because, again, the more you see them, the more you do them, the better it's going to be. Solve for x. So we're going to give our great divide just to keep our work neat, nice and neat. We're going to box in our Stinky Kid. What's the first thing you're going to do? What's on the side with Stinky Kid that's not attached to him? What number? Yep, get rid of the 2. Perfect. How am I going to get rid of the 2? Yes. Yes, subtract 2, because that's a positive 2, right? So we're inverse. -2, -2. If, and you know better than I do because you guys, I haven't gotten to deal with you guys enough or talk in person. If knowing which one's positive and negative and how to decide, The other silly story, I have tons of stories, guys, is if you're sitting in a classroom and you're positive, you're doing everything right, never in trouble, or you're sitting at your kitchen table and you're just, just chilling. And all of a sudden your mom or your teacher comes in and just like raises Cain and kicks you out because they want you to go to the other room. The first thing your teenage self does is go, but I didn't do anything. And then your attitude becomes negative, right? So again, like the money conversation, when it moves to the other side of the equal marks or crosses the great divide, its attitude changes. If it was, you've been in a classroom at some point where some kid like hates his teacher, just hates being there, they're negative, and the teacher's like, fine, just go sit outside. And then magically, like, they're the happiest kid ever because they just got out of class. So same idea. Once you get switched out, whatever you were becomes opposite. So G minus 2 equals 3x. Now, can G and 2 be combined in any way other than that? No, right, because they're not like terms. We have a variable and then a constant, right? So if it was G minus 2G, then they could be combined because then they're like terms. So good job on that one. Good answers. Now, what's my problem right now? What number do I need to get rid of? Who's over there with x that's got to go? Because we need x by itself. Yes, 3. How is 3 attached to x? Yep, 3x is the same thing as 3 times x. And to undo multiplication, we're going to divide. What are we going to divide by? What number? Ooh, good job, good job, good job. 3, 3, 3, right? Because it's 3 times x, so you're undoing this because you want the x by itself. So we're going to divide by 3. Divide by 3 because, again, these guys are in the other room. Not even a problem. Stinky Kid's over here. Got to get the 3 off of Stinky Kid. Now, this is a hot mess. If you were writing neatly, you were just copying exactly what you did. You subtracted 2 from G, and then you divided the whole thing by 3. So x is G minus 2 divided by 3. All right, I'm going for one more. One more, and then I'll hook us up for a game for like 5 minutes. I'll try not to keep you over, but they're really fun games. Especially if you haven't played the snowball one yet. Man, it's good times. All right, great divide. Here's our Stinky Kid. Who's on the side of Stinky Kid that has to go first? Yep, that 1. Exactly. What kind of 1 is that? Positive or negative? Negative, right? So like I said, if you're having a bad attitude, you don't want to be there, and then I'm like, you know what? Get out. You go outside. Is it going to stay negative, or are you going to be like, thank goodness I just got away from that crazy lady, and become positive? Positive, exactly. It's always the opposite, inverse, because we're undoing. Because if I owed you $1 and then I pay you $1, then we're clear on that side. So that side's good. Z and 1, can I combine those? No, good. Because I have a variable and then a constant. And now I still have 4x. So Stinky Kid's not by himself yet. Stinky Kid's attached to 4. That's multiplication. 4x is 4 times x. So to undo 4 times x, what am I going to divide by? Be careful. Yes, good. Divide by 4. Divide by 4. I was trying to be quiet enough, long enough to see how many people could chime in. Good. So z plus 1 divided by 4 is x. Big and ugly. Can't make it neater. He's a hot mess. It is what it is. It's not his fault he's ugly. He was just born that way. Okay? All right, I got 5 minutes. So let's do a quick game.